There we go. Figures. Okay, so we did balancing equations last time, so we're all good with that, okay? Now we're going to do types of reactions. Now with the types of reactions, don't write these 5 down. We're going to talk about each of these 5, so you have a chance to write them down in a few minutes. Like I said before, you guys are going to be given the reactants. You're going to have to tell me the type of reaction it's going to be. Eventually you're going to predict and write the products if a reaction is even going to occur, and then we're going to quantify it at the end. Okay? So you have to know these different types of reactions. It's very important. So the first one is this, combination synthesis. We typically show our reactions in a form of relationships. It is just what we do. It makes so much more sense to people if you somehow put our reactions in the form of boy-girl relationships. I'm going to tell you right now, I have no issue with whatever you choose to participate in is your choice. But in chemistry, you have to have heterogeneous coupling. It's just the way it goes. So please don't be offended with me because I'm not making them homogeneous. I can't. In chemistry, it's just how they go. Okay? Just so you know. So combination synthesis. This is what happens right before prom. You got a little girl dancing, the boy dancing. It's like, hey, we need a date to prom. You want to go to prom? Sure. Okay? So we have A, girl A, boy B. They come together. They are now a couple AB. Okay? They are in the couple AB. You have an element plus an element, and it makes a compound. And look what happens. Neutral element, neutral element. Now she's a cation because girls are positive and they should always come first as they walk through doors and things like that. So here's our positive girl and our negative anion boy. Okay, I'm a little jaded, sorry. Okay, so cation, anion, you made a new compound. When you look for combination or synthesis, combination is like, was the newer word for these reactions. The word synthesis is making a comeback. So you might see synthesis or combination. I'm not quite sure which one you're going to see in textbooks when you go to college. Okay? But synthesis means to make, So you see an element or an element. The thing is, it makes one product at the end, Griffin. One product is made. That's it. Okay? So like if you look here, 2 or more elements from one product. So form one product, sorry. So magnesium plus oxygen makes magnesium oxide. Sodium plus chlorine makes sodium chloride. Now here's a couple of compounds. Sulfur trioxide plus water yields sulfuric acid. So the thing they all have in common, one product, one product, one product. When you see one product being formed, it must be a combination reaction. Must. And you must recognize that. Does that make sense? Yes? Good. Okay. So I'm going to show you or demonstrate each of these different reactions so you can see what they are. So we're going to look at the formation of zinc sulfide. We're going to take powdered zinc, we call it zinc dust. It reacts much faster, much more fun. We're going to take sulfur, which, you know what sulfur smell like? Rotten eggs. Kind of looks like an egg yolk too, doesn't it? Okay? And we're going to combine these chemically and make zinc sulfide, which kind of looks like popcorn here, but it's really not. It's just this whitish, yellowish stuff. Okay? We good? Okay. Let me grab my little, you're coming with me. We're going to walk. And I'm going to, I'll put it right here for now. And let me go and get this. I left it outside. Org! I'm going to leave this door open for the meantime. And I'm going to turn on the vent back here. Possibly. Okay, so I'm going to take my sulfur, lovely yellow stuff here. So much fun. Put some sulfur here on this. Whoops. Give me a second. I put it upside down. I don't want that stuff running. So here's some sulfur. I was going to see what I'm doing right. You guys can come over here if you want. You don't have to. Okay. So I got some sulfur. And lid back on. I'm going to get some powdered zinc. Not yet, hopefully. And stick it on there. And you'll notice that nothing happens when I mix these two. Nothing. There's not enough what we call activation energy to make this thing go. Okay? It needs a little oomph to make it happen. And our oomph is going to come in the form of heat, in the form of a flame. Can I get someone to turn the lights off for me, please? Okay. So what I'm going to do, need a nice strong flame. Okay. Sure it all goes. It's very quick. Extremely quick reaction. Make sure it all burned off though. I don't want to move it around. And okay, if you would turn the light back on, that'd be lovely. You can see we got some burning sulfur in here. See the blue? Okay. And this is what, it's still burning. Stop burning. Don't want you burning. Suffocate it, come on. Okay, there it goes. That's what zinc sulfide looks like. Okay. My lungs are taking a toll today. Okay, so zinc sulfide. I'm going to show the camera. Zinc sulfide. So if I spill it everywhere. So this is zinc sulfide here. Yeah, sparklers, smoke bombs. They have all the same type of stuff in it.
What is the torture sulfur?
Well, because it's probably a better mixture. It's probably a lot better mixture of sulfur in there. I put a lot of sulfur to make sure it reacts.
It's a sparkler.
Yeah, but it smells like a sparkler, right, doesn't it? I know, it's stinky winky. There we go. See it? It looks like I'm going to. There we go. Okay, let me open this door up. Get some airflow in here. Okay. So that is a combination reaction. We chemically combined zinc and sulfur in a reaction. There you go. So now, here's what happens after prom. Decomposition occurs. Okay? So you got the dancing little girl and the dancing boy, and then all of a sudden after prom, you're like, oh. After prom's the worst. You go in the bathroom, girls are there crying. Oh, I can't believe it. He liked me a lot. Well, sorry. So here's a little girl back here, all by herself. The boy's all by himself. So we have A, B. They start off as a couple. Yay. Prom's over. No need for coupling anymore. So A's by herself and B is by himself. They go from being a cation and an anion back to neutral elements. Okay? You will have to recognize these. You will have to recognize that you start off with one substance, and that one substance then breaks down into two or more substances. I know, it's a little, should be here all day. If you have dogs when you go home, when I go home, my dogs will come to sniff me and they'll go, they'll raise their teeth at me because I stink. They're like, what's wrong with you? You know, so let me know tomorrow if your dogs give you the evil snare. Okay? So, if you look at this, mercury 2 oxide decomposes into mercury and oxygen. One thing breaks apart into two or more substances. Here's the potassium chlorate, breaks down into potassium chloride and oxygen. One thing breaks down into two or more substances. That's how you identify a decomposition reaction. We good? Yeah. Okay. Now I'm going to show you the decomposition of hydrogen peroxide. Hydrogen peroxide is something most of us have in our houses. We put it on our little wounds and things like that for, okay, the antiseptic. And what I'm going to do, I'll put this on here so it doesn't fall over. That would be bad. Okay, I got it there. Now, this hydrogen peroxide is 30%. 30% is nasty. You use 3% on your cuts and wounds. If you get your hair bleached out before you color it again, or if you bleach your hair, it's 6%. This is 30%. If you spill this on you, you'll know it immediately. Your hand will start blistering. Okay? It turns white, it blisters, it is just no fun. Okay? So just know this is nasty stuff. And also, we put it in this accordion bottle because it decomposes on its own all the time. Even though it's in a brown bottle and the light can't really hit it, it will slowly decompose on its own. And if we want to make sure there's a lot of room for this stuff to decompose into. Sometimes it's like this, and we'll just go by and we open it up and we'll tighten it down again so it has more room to expand. Okay? So anyway, actually, will you turn the light on for me, somebody over there? So I'm going to take some of this. Make sure I can get it all cleaned out. All the way on. Yeah, this is a. And I'm going to put some peroxide in here. Okay, we don't need much. And then I'll take this out. Put it back over here. Now, it's decomposing right now. Nothing great. It's really, really slow. But I'm going to speed it up with a catalyst. A catalyst is a substance that goes into a chemical reaction with the reactants to speed it up. It's not part of the chemical reaction. It's just there to say, come on, let's go, let's go, let's go, let's go. It's like the Match.com. Match.com gets two people together, but it doesn't go on dates with them. You know what I mean? It's not part of the relationship. That's what this stuff does. It just speeds up the reaction so that we can see it quicker. So this is manganese 4 oxide. Goodness gracious. Oh, here it is. That was smooth, wasn't it? There's your pure oxygen coming out. If you want to come back and waft, ooh, waft, water and pure. Come and smell. It smells so clean. It's wonderful. It's wonderful, especially after that awful. Come back here, walk around, smell. That's wafting. You smell it? It smells so good. Come over towards me. I think it's come this way. Can you smell it? You smell how clean it is? Doesn't it smell clean and fresh? Yeah.
I do smell it.
Oh, I love that smell.
That smells like air.
And then, also, it smells like very clean air. Then also, do me a favor, touch the bottom of it. Actually, touch the side. What is it? It's very hot. This is extremely exothermic. Extremely exothermic. Yeah, touch the side. Very, very, very hot. You guys agree?
Yeah.
Yes. I'm not going to walk around with it all because I think I want to get through some of this stuff. Okay, so then get it cleaned up for a minute. Come on. Probably a terrible angle for that video. Okay, let's leave it like that. Okay, so or decomposition reactions. Fun, fun, fun. There's my little guy I'm walking around with. Okay, so now we know combination reactions and single replacement reactions, correct? Yes? Yay. Okay, quick little check. What's this reaction up here? Combination. What's the second reaction? Decomposition, and then the final one is combination. Sorry about the arrow being messed up. Good. Okay, now we're getting kind of weird here. Now it's a single replacement reaction. This is why the breakup occurs after prom. Okay? You've got, here you guys are dancing, this little couple's dancing, having a good old time. And look, in comes Kevin. Kevin's sliding it backwards, moonwalking into the party. And she's like, oh my gosh, what a great dancer you are. And then these guys start dancing. They become a couple. And then poor Sam's off by himself. Oh!
My music's cool.
I kind of did, actually. I looked over and went, hey, that's like Sam. So, yes. Okay? So, you start off with a couple, A, B. You introduce C. You have a compound and a single element. And it makes a new compound and a new single element. Hence the name single replacement. You're singly replacing one element. One comes in, the other comes out. Okay? So far, so good. So, this is a compound, so you got a cation, an anion, and then just a single element. Then the same cation, anion here, and a different element comes out. The anions have switched places. Are we good? Yes? Okay. And so examples of this are zinc and hydrochloric acid. One element replaces another element in the compound. So zinc goes in, hydrogen comes out. Hydrogen thinks it's a metal. It's a cation. It's not even just a metal, it's a cation. And because it's a cation, one cation comes out, the other cation goes in. Down here, iron is by itself to begin with, copper is by itself to end with. Single replacement reaction. Does that make sense?
Yeah.
So I'm going to show you a single replacement reaction. I'm going to show you actually this one right here. The zinc with the hydrochloric acid. Zinc and hydrochloric acid is a single replacement reaction. I'm going to take some zinc and I'm going to put it into some hydrochloric acid, and you're going to see the hydrogen gas is being produced. And we'll make zinc chloride, which is a clear, colorless liquid, at the end. You good? Okay. So, Leanne, would you get the lights for me, please? Turn them all the way on, please. Now this time I'm going to put him over here. I decided...
Get a different angle.
Yes, a new angle here. So, would you shut the door for me? It's actually really chilly willy. Okay, now this is 12 molar hydrochloric acid, and so there's an acid left, so we can just go from here on this one. I won't need the. I'm not going to do it yet. Okay, so I've got some mossy zinc in here already. I'm going to add a little more mossy zinc. Mossy zinc, they just take molten zinc and put it in the water. We use zinc powder the first time. This time, we're going to use mossy zinc. It's going to slow the reaction down. We don't want to use hydrochloric acid with powdered zinc. Isn't this pretty?
Front door closed.
No, it's fine. Yeah. Okay, this is so pretty. That big old chunk. It's like aluminum foil, doesn't it? So we just put it in here. Give us some nice fresh magnesium or zinc to react with. Okay. Then I need a helper. Oh, grab it. You gonna get your goggles on for me?
Glasses?
Yeah, you need goggles. Okay, I need you to come over here. I'm gonna push this trash can in. And I would like for you to pour this 6 molar hydrochloric acid, which is extremely concentrated, so please be careful. Well, he'll move in a second. So I need you to pour it in here slowly, but quick enough that you capture a reaction. Just
Without
don't
a
get
filter?
without a funnel. Yes,
Right
you can
now?
do it. Yes, go ahead. Just trying to get it everywhere. Keep pouring. There you go. Yeah, good job. Keep going. Okay, well done. Okay, and what we're going to do is we're going to capture the gas. Ah! We're not going to capture the gas that much, are we? Scared me. Oh, come on. There we go. Oh, my balloon's got a serious problem, doesn't it? There it goes. So we're going to capture the hydrogen gas. Because what do we know about hydrogen gas? Hydrogen gas is
Lighter than air.
lighter than air. That is true. It's also very flammable. Do you know what they used hydrogen gas for back in like the 1800s? Not lamps.
Cigarettes.
Not cigarettes.
Rockets.
Not rockets.
Cannons. Airplanes.
Nope. Modes of transportation. They did it. The Zeppelins. The blimps. The Hindenburg was a hydrogen-filled blimp, and we know what happened to the Hindenburg, right? Okay. Wasn't the best idea they've ever had. So I don't know. It's going to get much bigger. So let's see. I hate tiny balloons. They pop on me all the time. It scares me. Okay. So it is lighter than air, right? Now let's test the second thing. Is it flammable?
Hope.
Oh, come on, bud.
Do I need my goggles back on?
Yes.
I need to be careful about this.
Now, because I don't want you blowing yourself up. Well, that's true, but we are going to. Can we turn off the lights for me, Tim? And you're going to stay this far away.
Is it like taped on there?
Yes, it's stuck on there. I'm backing up. It's all you, bud. Put it under it. Yep. There we go. Fun, fun, fun. Okay. Lights back on. But see, you gotta understand. That's fun, but that's not. No, leave it on for now. That's not Cottingham fun. Cottingham. That's just not enough. Okay. So, what we're going to do, add a little more hydrochloric acid in here. Okay. Okay. We know that if we want something to burn better, we add oxygen to it. So, what I'm going to do here, and Cole, you're going to come help me again, or is someone else going to help me?
No, I got it.
Okay. Well, yeah, you did a good job the first time, so I'm going to trust you the second time. Okay. Now, I'm going to do the decomposition of hydrogen peroxide to get some pure oxygen. That's the only way I can get it. Not the oxygen in the air is only like 20-something%, so it's not very good. I need 100% oxygen. So, what we're going to do is this. Actually, you can light it all the way on for me so we can at least see this part, and then we'll. Okay, so I'm going to put some peroxide in here. 30% hydrogen peroxide. Yay, 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 yay. Don't need much. Okay? And this time, to make sure, come on. Oxygen's not actually flammable. Oxygen cannot burn. It just helps things burn. It promotes combustion. Oh, well, I'll do it later. Well, it's all wonky. Okay, so what I'm going to do, I'm going to take some manganese 4 oxide here. I'm going to put it down my balloon. It is. It's going to be fun. Okay, I'm going to take this off. Now, once this happens, we got to work a little more quickly, okay?
Pour it quicker.
Not yet, not yet. We got to do this first. Look at me. He's all gung-ho. Not yet. You wait.
I'm just holding.
Okay. Let's fill this up first. Let's get our oxygen in here first.
Oh, that's making oxygen.
Uh-huh. This is pure oxygen.
Why am I not hydrogen?
We're going to put the hydrogen in a second.
Got it.
We just got to get the oxygen in there first.
Are we creating water?
What?
H2O.
Yes, we're going to make water at the end. Good job. Well done. See? Okay. So, let's see if I can put a little bit more in there. Let's have a little fun, shall we?
Yeah, as long as it doesn't pop right here.
Oh, God. Ow. Hot, hot. Hold this for me. Really quick. Okay? Not yet. No, no, no. Absolutely not. No, no, no. No. Okay, I think I picked the wrong person.
I thought you said go.
No, 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 no. I said no. Okay. So now we're going to put the hydrogen in. Okay, so go ahead and put the hydrochloric acid in.
Now?
Yes, now. Well, yeah, now. Okay, stop.
Stop.
Yep. Oh, son of a gun! Ah! It went away! I gotta do it again. Oh, so sad. Okay, here we go again. Okay, stop. I demand a recount. Okay, here we go again. So we got this. We'll have to edit this, won't we? This is not going well on film. Hydrochloric acid got on you? It probably didn't. It's not up in the balloon. You probably got some water on you.
Am I contaminated?
You are not contaminated.
I need to use the shower.
No. Well, you might need to use a shower, but not because of this.
I promise I showered.
Okay, well, good then. That makes me happy. Okay, here we go. I work better more quickly, so let's see. Got this.
I'm not going to touch that yet.
That's a good idea. Thank you for recognizing it. Okay, well, that does a good idea. Okay, let's do this. Okay. Yeah, that's all good. You notice the stuff on the ceiling up there. Last time that balloon popped on me and got the stuff everywhere.
Good.
Okay, here we go again. Here we go again. Whoa! Holy cannoli. Batman.
Do they have to change the tiles in your room? Or the...
I take them around. I'm not just going to tape it. You take them around and hand them to people sometimes. Oh, that. Okay, your turn. You're up. Okay, not yet. Not yet.
No.
Not yet. Nope, nope. Okay. Okay, let me get this. Let you get it so it's not. Okay, 1, 2, go. Okay, stop. There. Yes. Okay, now let it fill up for a few minutes. Got it. Okay. Now I want all you guys to go out in the courtyard. Just go right out the door. No, you stay here, Cole.
No! Let me pick our phones.
Actually, would someone carry the swivel bibble with me? With them?
Explode, dude. You're walking right past it.
Is it?
Yeah, can we get a bonus?
No, you'll see it on here. Okay, so
Well, that's, yeah.
what we're gonna do is this. We're gonna take this. It's gonna be amazing. I should be talking like this. It sounds great. Okay, so oh gosh, that's not good though. Well, we're gonna let it be. Okay. Okay, ready for this? It's not too windy out there. Okay, now here's what I want you to do. We're going to. This is the Bunsen burner we need. I need you to take this out and light this for me. Okay? So let's take it outside. You got the lighter? Put the we'll put this go away over. Keep going. Okay. Go by where Sam is standing. Can someone hold the door open for me for a second? Okay. Get it lit for me. Oh no, are you serious?
No, hold on.
Don't get too close to it.
Ah! That'd be so bad. That'd be so bad. 9. You get it? Get another lighter. Did you get it? Oh goodness. Is it going? Okay. Good job. It's a clear. Okay. There we go. Okay, everyone back up.
Hold this.
How far back should he be?
Pretty far back.
All we talked about.
Okay, fun. Okay, come on in, guys. Is it on me? It's on fire.
Watch out, watch out, watch out.
I'm like, what are y'all talking about? Okay, come on in, guys. Okay. Oh gosh. Will someone get the phone for me? There you go. Thank you. Hi, Swivl. Yes. You should watch it. Okay. Oh, you have to leave.
Yeah.
Okay. Okay. You like it?
Yeah, but your parent like it was
Yes. 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 It's all under control, Mr. Reeve.
Your parent like was like that far away from that kind.
Okay. Yeah, if you don't mind. Yeah. Okay, so wasn't that fun? I did that one year, and before I realized how powerful the thing is. I did it in here, and all the ceiling tiles in the lab went up and came back down, and all the floor, it took weeks to clean up. My clock fell off the wall and broke. I knocked off glassware. It was, I mean, and everyone was running down here going, what happened? I'm like, so now we take it outside. That's why, trying to get it outside. But it's fun. Oxygen doesn't burn. It just helps things burn. So that's why I always laugh, when something blows up in space, you're like, because like the oxygen tanks will blow up in space, you're like, they might blow up. So how can they do that? Let me give you your homework. I'd hate to see you leave without your homework. That'd be terrible. You almost got out. You almost escaped. There you go. Bye. But anyway, so single replacement reactions are a lot of fun. They're probably the most fun of the reactions. So, and that'll be it. I think.